So in this video, we're going to do the second part of the objectives for the day, which was to condense logarithms into a single one. We're still going to be using the properties, so if you need to review those, make sure you have those nearby, because I will be referencing those in this video as well. So when you're condensing, you're going to rewrite multiple logarithms as a single logarithm. So when you see these words in an example, for example, if I say condense 2 times the natural log of x minus a times the natural log of y, you should understand that there's two logarithms here. You need to rewrite them as a single one, which is exactly what we'll do. So this is in reverse order. We're first going to deal with the exponents out front. So I'm going to rewrite this as natural log of x squared minus the natural log of y to the power of a, whatever a might be. And then in the final step, I'm going to take this and say it's the natural log of x squared divided by y to the power of a. Notice I now have a single logarithm. It's right there, right in front, the natural log there. And I'm actually done with this problem. Please make sure that you include the logs in your final answer. Don't just give me x squared over y to the power of a. This is wrong. It needs to have that logarithm out in front. Okay, let's try another one where we kind of beef it up a little bit. Let's take, let's say we're going to condense. Let's do 1/3 log base 2 of a minus, let's do 3 log base 2 of b plus 7 log base 2 of c. Okay, so there are 3 terms in this case, but once again, we're first going to think about these numbers out front. Those are the exponents. So I'm going to rewrite this as log base 2 of a to the 1/3, which in a minute I'm going to rewrite this as the cube root of a, minus log base 2 of b cubed, plus log base 2 of c to the power of 7. Now I can actually start combining. So this means I'm going to have to divide, and then this means I'm going to have to multiply. So the final answer is going to look something like this: log base 2 of, let's do cube root of a, because that makes a little more sense than a to the power of 1/3, divided by b cubed. Now sometimes the question comes up, where does the c to the 7 go? The c to the 7 goes up on the top. So it's not always going to be the case where you just take, well here, let me write this as the final answer. So this is the final answer. Now let me show you where some confusion comes in. A lot of times I see students look at this part and they say, well, c to the 7 has to be multiplied by b cubed, right? But keep in mind, you're not really including that negative. So what's really happening here is, if I'm kind of including that negative portion, I'm dividing by b cubed, or you could rewrite this to say log base 2 of c to the 7th minus log base 2 of b cubed. Now it makes a little bit more sense. The c to the 7 is going to be divided by b to the power of 3. Okay. Now before we get into any more examples, I want to point out that a lot of times if you have log base b of something, I'll just call it x here, this is often written as just log base b and then they put the x there. Or I could just do log of x. A lot of times this is just log of x like this. That's totally fine. I like to use parentheses just because otherwise it looks like a long string of letters and it's hard to tell where everything goes. So I often use parentheses for everything. But if we were, say, going to do the second example again, you might actually see it like this, say on Delta Math or in textbooks or somewhere. You might just see 2 ln of x minus a ln of y. And it's assumed that we have parentheses there, so then you could rewrite this as the natural log of x squared minus the natural log of y to the power of a, and then we would end up with the natural log of x squared. Oop, that's an a, not a 9. And so you might just see it like this. So this is just something to note, to keep in mind. A lot of times this happens. I will accept either of them though, as long as they're correct. So I would encourage you to use parentheses, but it's really up to you. Okay, so we're done with the main part of the lesson. You should now be able to expand and condense logarithms. You have all the tools needed to do that. You've seen some examples. There are, however, a couple of other examples I want to take a look at, just so you feel a little bit more confident on your Delta Math practice. So let's change things up a little bit and use more numbers rather than using so many variables. So we're going to condense 1/2. Now notice I'm going to use a b for the base. I don't really care what the base is in this case. So it's 1/2 log base b of 9 plus 3 log base b of 2 minus log base b of 6. Now the reason I like these expressions, expressions, is because you actually get to simplify some of these numbers. Instead of having all these variables thrown in there, you should end up with a single number. So your final answer should look like this. You should have log base b of some number, which is kind of nice because if you look at the previous examples, we have a to the power of whatever and x to the power of whatever and all these other things. So I kind of like how these work out. So we're going to start off the same way. We have our numbers out front, our exponents. There's just a 1 there, so we don't have to worry about it. So I'm going to rewrite this as log base b of 9 to the 1/2 plus log base b of 2 to the power of 3 minus log base b of 6 to the power of 1. So as a reminder, 9 to the 1/2 is the same as the square root of 9. So this is actually 3. So let's go ahead and before we actually combine these, let's take a look at what all of these equal. So I have log base b of 3 plus log base b of 2 cubed, 2 to the power of 3 is 8, minus log base b of 6. Now I'm going to rewrite this as a single logarithm, so it's going to be 3 times 8 divided by 6, which ends up being log base b of 4. And that is my final answer. We're not going to take it any farther than that because we don't know what the base is. So that is an example of condensing still, except there's a couple of extra steps where you actually have to figure out what the numbers equal. Another type of example we might do, again dealing more with numbers, we're going to say that we're given some information. So I'm going to tell you what log of a is. I'm not going to tell you what a is yet. I'm just going to say log of a is 3. I'm going to tell you that log of b is -1. And I'm going to tell you that log of c is 4. Given this, I want you to evaluate the following. So evaluate means you're going to actually end up with a single number as your answer. So here's what we're going to evaluate. Log of the square root of a cubed b to the 5th all over c squared. Okay, so for one, I'm adding something new here. This is new by giving you all of this information. But also this square root over the entire expression here, that's also new. And this kind of gets back to properties of exponents, which I don't think I reviewed this property in the previous video. But when you have an expression like this, a cubed times b to the 5th, you can actually rewrite this as the square root of a cubed times the square root of b to the 5th. So the square root, you can kind of think of it as if it distributes to each term. It does not work if you're adding those. So if you're adding a plus b under the square root, you cannot put the square root on each of those. And as we know, in exponential form, this means a to the 3 halves times b to the 5 halves. So now we have the tools we need to actually expand this. So let's rewrite it first of all as basically what I just wrote. Log of a to the 3 halves times b to the 5 halves over c squared. There we go. Okay, now we're given a single logarithm, and we know the values of these logarithms, but I currently don't have those logarithms in here. I don't have log of a yet, I don't have log of b yet, and I don't have log of c. So this is really an expand problem in disguise. So I'm going to put that over here, expand problem in disguise. So let's expand it first, and you might not know exactly why I'm doing this, but at the end of the problem it should start to make a little more sense. So we're going to go ahead and expand. I'm going to skip a step. So it's 3 over 2 log of a plus 5 over 2 log of b minus 2 log of c. So notice I've skipped the step where I just wrote the adding and subtracting, and I went straight to the final part where we've taken the exponents out as well. Now what I can do is I can actually replace each of these, log of a, log of b, and log of c, with the values I had up here. So let's do it. We're going to have 3 over 2 times log of a, which is 3. We're going to have plus 5 over 2 times log of b, which is negative 1. And we're going to have minus 2 times log of c, which was 4. Now multiplying all these out, you could just use a calculator to do this. In order to multiply, we would end up with 9 over 2. This is going to end up being minus, I was about to write plus, minus 5 over 2, and then minus 2 times 4 is 8. And so I end up with 4 over 2 is just 2 minus 8, which is negative 6. We could double check this on the calculator. So let's go to our calculator here. 3 over 2 times, times 3 plus 5 over 2 times negative 1 minus 2 times 4. So it is in fact negative 6. It worked. Okay, and so that would be the final answer. So at this point, once again, the main goals of this lesson were to expand and condense logarithms. At this point, you should have the tools necessary to do that. In addition, we kind of did some other sort of weird looking examples that still deal with expanding and condensing, but they get into a couple of other details that I like to throw at you as well. So you should be able to solve all of the delta math at this point based on these examples.